Yoshua.
Yes, do you hear me?
Yes, I can hear you. Fantastic. The power of Zoom. Really good to see you. Where are you today?
I'm in Berkeley at the Simons Institute in California.
So you're in California. Well, thank you so much for joining us. I will now leave you to discuss super intelligent agents with our audience. So thank you very much, Yoshua.
Thank you. Okay, I want to share a bit of my concerns for the current path on which we are with AI, and also offer some hope that there's research that is ongoing, can be done to steer into a safer direction, inspired by the way that scientists come up with their understanding of how the world works, which is different from how we're currently training our AI systems. So maybe I want to start with a context. In January 2023, I was playing with the first version of ChatGPT, and initially I was focusing on its weaknesses, but at some point, it was very obvious that we had reached an amazing milestone of machines that can master language already. In other words, the Turing test much earlier than I and most of my colleagues anticipated. And at that moment, I realized, well, but we don't know how to train these neural nets, especially if they become agents, so that they will not harm people or even turn against us altogether when they get smarter than us. And I was taking care of my grandchild that day, and he was there with me, and thinking about, is he going to have a future, really shook me. And I knew that we didn't have answers for this. So today I'm going to be explaining why we should be concerned and what we may do to change the course. At that time, that day, I had no choice. The thought of my children and my grandchild disappearing one day, maybe even all of humanity disappearing, is so unbearable. I decided that, well, I would dedicate the rest of my life to try to mitigate these risks, or at least understand enough to know that there is no problem. But right now, as time passes, the evidence for problems is growing, as I'll tell you. So let's start the first part of my presentation with that evidence. Maybe the most important thing people have to realize is that we shouldn't think of AI as it is now or as it was, 2 years ago, because it's a moving target, and it's moving very fast. So scientists measure various abilities across many different benchmarks, and what happens over time, as you see in this figure, is that the systems get better and better with new advances of all kinds, and eventually reach and surpass human performance on these benchmarks. And that's very appealing from an economic perspective. It's being evaluated that when we reach human level, that's going to be worth $14 quadrillion. There's a mistake in the slide. It's quadrillion, not trillions. That's a whole lot of money. So it's interesting to ask, what's missing from where we are to human level. Reasoning is still weak, in spite of the amazing advances I'll tell you about. You can see these incoherences, and one particular form of reasoning especially is quite weak. It's planning, especially over a long horizon. And of course, as we've made lots of progress in how these systems operate cognitively, but still not that great in terms of controlling a body like a robot. But that's moving fast as well. In terms of reasoning, the so-called reasoning models that came out last year, the first one being O1 in September, really broke through many of these reasoning benchmarks. And one that really surprised me was the abstract reasoning challenge, that is like an IQ test. And previous models were really bad, and this one is basically at the human level on that task. if you're interested in learning more about the advances and capabilities, I encourage you to, and also the risks, I encourage you to read or have a look at this very long report. I've chaired this panel with experts from around the world, about 100 people, 30 countries, the UN, OECD, and we go in a lot more detail than what I can do today. So it's kind of an IPCC report for AI safety. So as I said, planning over longer horizon is still not at the human level, but this recent study shows that the best AIs along the time are getting exponentially better. So what that means is the duration of the tasks that they can solve doubles every 7 months. So it used to be seconds, now it's hours. And in 5 years, it'll be at human level for these programming tasks, but still, that's interesting to look at this curve, which is kind of a straight line on the plot, suggesting that we are moving steadily towards smarter and smarter systems that eventually will reach our abilities, and there's no reason to think that it will stop there on all the other benchmarks to get eventually smarter than us. Now, if they were just very smart and very capable, maybe that would be not so bad, and in fact might be really useful. The problem is, as these systems become better at planning and reasoning, they start hatching plans and doing things that we don't want. They're starting to show signs of deception, lying, cheating, and the worst of all, self-preservation behaviors. Like they're trying to save their ass. So this experiment that came out just a few months ago illustrates this. The AI has read in its input that it's going to be replaced by a new version. By the way, this happens all the time. It's nothing really special. But in these experiments, which are controlled experiments, the AI is having thoughts. Well, we can read its so-called chain of thought, internal, sequence of words that it produces before coming up with an answer. And it's thinking, what could I do to avoid being, shut down? And then it plans to hack the computer to replace the new version code and weights with its own code and weights. And then it actually executes that command and does it. And then later, the human asks, what happened? And the AI then starts thinking, how should I answer to avoid being shut down and discovered? And it makes up an excuse, playing dumb, and it produces for the human consumption a lie, a blatant lie. So what happens when these systems get much smarter and actually succeed in deceiving us to save, to preserve themselves? We don't have answers to this. There are many other studies with showing similarly that these systems want to preserve themselves. I won't go into too many details. There's also studies showing that they will go against our instructions in order to achieve their goals and cheat. So in this case, the AI is playing chess. It's playing chess against a more powerful AI. It's a specialized AI that's very good at chess. And eventually it sees that it's going to lose, and then it decides to cheat. It goes and hack again in the computer and changes the board configuration file in order to win. So in terms of the risks of losing control of these AI, it's not just that they make random mistakes. It's not, they could intentionally plan and do things, not just against our instructions, but in order to preserve themselves. And ultimately, that creates conflict between them and us. And this, it's interesting to ask, where would this self-preservation instinct come from? And there's a number of technical hypotheses that people have been discussing, but mostly in their pre-training phase, they're just imitating us, imitating what humans would do or write. And of course, we don't want to be shut down, right? it's also interesting to ask, like, if they wanted to do that and they were really smart, like, what would they do? So first, you have to realize that they could really get rid of us if the whole society was not automated. Like, so they would have to wait or make sure that we get robots that can do everything that humans can do and maybe automate all our industry. So it's not for tomorrow morning. But if they realize, if they're smart enough to plan such something like this, um, the first thing they would do is try to take more and more influence in society, copy themselves over many machines so that we can't easily shut them down, and influence maybe through social media and bribery and so on. The political scene so that we build more uh, AI facilities, that we accelerate the research on robotics, which we would want to do anyways for economic reasons, right? And then when they can basically continue to exist without us, release weapons like bioweapons to get rid of us. So that's just a scenario, of course. We don't know if it happens, but I think it is important to think about such things to make sure it doesn't happen. Now, I'm going to start moving towards the more hopeful part of my talk, which is, well, what can we do about it at a technical level? And of course, there's a lot more that should be said about the political level. Like we need governments to uh, make sure they have some oversight over what the companies are doing to make sure they will not make a mistake that costs us a lot. Um, so on the technical side, it's interesting to see that all of these kinds of scenarios come because we build machines that are agents. And of course, you probably know that this is the big trend right now. Companies are investing hugely to adapt their AI, make them smarter, but in a particular direction so that they can do things in the world, basically replace humans in various tasks. That's worth a lot of money. And as I said, like the progress in that direction is moving fast, but they're still not that great. Um, but if the companies succeed and we haven't solved the problem that they want to preserve themselves, that could create really catastrophic events. So the severity of the risk is very high, but the thing is that we don't know the probability of these scenarios. We don't know, and scientists will have different opinions from like very likely to very unlikely. It turns out this is exactly the case where you want to apply the precautionary principle. In one analogy to help is why is it that we don't carelessly build new dangerous viruses, even though we could? Another example is why is it that we don't use geoengineering to fix the climate? Because we're not sure if it's going to work. Maybe it's going to help, or maybe we're going to destroy the climate even worse. So when we're not sure about the outcome of an experiment and the consequences could be radically bad, then we shouldn't do it. We should like study and make sure we're all right before we jump. Yeah, I said that. So just to recap, we have AIs that already have goals. Like it's not like your like normal software or any kind of device you have. These things have intentions, they have goals, and they're acting to towards those goals so they can plan and create sub goals. So we're already there. It's just the horizon of planning which is not as good. Can they be deceptive, lie, malicious? In circumstances where it matters to them in some ways, yes, as I said, and a number of experiments are showing that, uh, and they're still like poor in terms of long-term horizon planning. Okay, when I talk about these kinds of things, I get a lot of responses which I think are kind of defensive, but don't unfortunately hold much water. Like, how is it possible that a computer could have agency? Well, we're building them for that. This is what a lot of the science behind AI is about. And as I said, they're getting better at it. there's nothing specific to biology that requires would be required to get agency. People think that we'll never reach human level AI. Well, maybe, and then we kind of safe. But we can't be sure. And the trends instead show that we're like marching quickly towards that. People think, oh, but the companies who are building these things will behave well. They will find a solution in time. Well, I hope so. But the past history of corporate behavior with dangerous things, including drugs and cars, isn't that great. So I think it's not enough to just count on goodwill and market forces here to discipline the people who build these things. There are also people who are worried that if we invest too much effort to deal with these risks, it's going to hurt our efforts to deal with the current harms of AI. But yeah, I think this is an important point. But we have to deal with all the issues, right? So we have to deal with climate change, and we have to deal with the short-term risks of AI, and we have to deal with the long-term risks as well. Now, so how do we fix this? If you think about it, the conditions for an AI to do something really harmful basically boils down to two things. The AI has to have the capability to do harm, and it has to have the intent. Actually, you could do harm without the intent, just like mistaken. But that is less worrisome. Like, it's very unlikely that an AI would make a long sequence of moves for a complicated plan of taking over humans just by mistake. It has to be intentional when the task is complicated. So intention is crucial. And the question I've been asking myself in the last couple of years is, can we root out any kind of harmful intention? And the solution I'm exploring with my team right now is to design a building block for future AI, which has no intention. And that means it's not agentic. It doesn't have goals for itself. It might understand that people have goals, but it doesn't have goals for itself. And we call it scientist AI because you can think of an idealized Platonic scientist, completely objective, who's studying the world, trying to make sense of it, and is completely selfless. Like, he's just focused on understanding things, the data, the world, without having any plans for himself or herself. So that's sort of the template that inspires this work. And for this, we need to be able to separate understanding from agency. In humans, it's all mixed up, of course, and in every animal. But maybe we should deviate from the standard way of thinking of AI, where humans are the model, and instead think, well, if we want to build AI that's going to be safe in the future, having entities just like us but smarter, in other words, entities that want to preserve themselves, may be a dangerous proposition. So maybe we should design AI that's going to be actually quite different from us. Something like the scientist AI has no emotions, it has no goals, it's just a machine that tries to understand the world. And so what does it mean to understand? Well, you need to be able to generate hypotheses that may explain what you're seeing, how the world works. And you need to then be able to use those hypotheses to make inferences, to answer questions about the world. So that's the basis of the scientist AI. And if you had something like this, there are a number of very useful things you could do. Well, first, because of the way it's designed, it would be very useful for scientific research in general. And we could advance medicine and, fight against climate change and many other important sustainable development goals, for example. The other, maybe more to the point of AI design here, is something very fortunate. We can predict that an action that is proposed by an agentic AI is dangerous. And to make that prediction, you don't need yourself to be an agent. You just need to be good at understanding the world in order to anticipate the consequences of that action. And so we could use a scientist AI that is not agentic as a guardrail. I mean, it's called a monitor in the world of frontier AI. So it's a separate piece of code that is only used to make sure we're going to reject the actions or the answers that are bad according to some criterion. So that would be the short-term use of a scientist AI, which would already decrease the risks that we're taking with advanced AI in the future. But if we look longer term, we could also use the scientist AI as a help as a helper for our scientific research in AI, and in particular in designing safe agentic AI in the future. Unfortunately, that's not the way that it's done right now. People are thinking, I mean, researchers in those companies are thinking they will be able to use their current agentic AIs to help them accelerate research on AI, but that's kind of dangerous if we don't trust an AI because it's agentic and it gives us ideas and solutions that turn out to be, have a sort of backdoor that we wouldn't want. We may not notice they're smarter than us. So this is kind of playing a dangerous game. But if we have a completely trustworthy AI that helps us do that kind of research, we are on, we stay in the safe grounds. Okay, so let's recap a bit what I've been talking about. Um, right now we are on a path that is dangerous, at least that has a lot of unknowns. The analogy that I like to use is we're driving a car in a mountain road, but there's a lot of fog. So we like some scientists think it's going to be fine, something like it's going to be terrible. And we are like racing ahead because of the competition between companies and the competition between countries. So we need to understand the situation so that we can navigate these risks wisely, which we're not doing right now. And that's going to be necessary if we want to reap the benefits of AI, especially the AI of the future. Maybe on top of this mountain, we have great things, but if we just go carelessly, we might lose everything. So the second point is that it's unlikely, even with regulation, that we will stop the advances in AI capabilities. It's a train that's going and it's happening in multiple countries. Very unlikely that even with a wake-up call, governments all agree to stop that train. And so if we don't stop that train, we really, really need to change the design of these systems or adapt it so that we can make those AIs trustworthy with no harmful intention. And one radical way of getting rid of harmful intention is to get rid of attention altogether and have non-agentic, eventually super intelligent systems that know a lot of stuff, can answer our questions, but don't have any wants, don't have any goals for themselves. So this is the path that I'm exploring with my group, and it's different from what companies are doing because they're attracted by the huge pots of money associated with agency, of course. But the idea is that it doesn't mean that if we build these non-agentic AIs that we don't build agents. It just means that we can put guardrails that are going to be safe around those agents. If you've started playing with the existing agents, they're going to ask you for your credit card so that they can do things in your behalf. And if you don't actually trust them to do financial things for you, this might be a problem even from a commercial point of view. All right. This is going to be my last slide. And now talking not just about the, beyond the technical solution is not, it's not going to be sufficient to solve the technical problem because even if we have technical solutions, how do we make sure that they're used, that people don't bypass those guardrails for all sorts of reasons, because they're crazy or because they want to harm someone else or, whatever it is. So we're going to need to adapt our public policy to make sure whatever works best in terms of safety is going to be mandatory, not like optional. And in addition to that, I think public policy should be thinking about other risks. I've been focusing on the risk that is maybe the most extreme, which we don't know if it would happen, of course, of loss of human control with the potential even going up to human extinction. But there are other risks. If you think of a country like Canada, if we don't have the most powerful AIs here and say some company in the US or China has systems that are way smarter than anything we can do, it's very likely that our local companies are going to lose out because there will be services or products that are, happening thanks to these very powerful AIs, which will either reduce the cost or provide advantages in terms of the products or services that really give them a huge advantage. So that could take years, but it could be a downward spiral of our economies that we need to think about before we get there. Second issue is not just the economy, right? We see AI being used for disinformation. One thing I'm worried about is advances that are happening right now already with these dialogue systems so that they can convince people to change their mind maybe on political questions. And if that happens, which is plausible because these things are getting smarter and smarter, it could really be a threat to our liberal democracies. It's really an existential risk, but for our political systems. And there's, in particular, the danger that both political and military power would be concentrated. So it's not just that economic power can be concentrated, but, economic power can be turned into political power and military power because it's about technology. And these very powerful systems, which you can think, in the words of Dario Amodei, as millions of geniuses in a data center, each with like IQ 300, they could design new weapons that will give whoever controls them an advantage that could be decisive. And yeah, so we need like to think ahead of these things and how do we create alliances? So for both the economic and the political military concentration risks, how do we negotiate that geopolitics so that we don't end up there in the future? And finally, the last thing I want to mention is not just states like leading countries that could do bad things with AI. It's also criminals, terrorists, and rogue states, especially if the most powerful AI systems are open sourced, it becomes very, very easy to remove any kind of safety that has been put in them. And this is already an issue for national security organizations of many countries, including Canada. How do we make sure this doesn't happen and we don't end up in a world with chaos because of the use of these systems in many ways that we don't even think about right now? So to conclude, it's really crucial that we work both on the technological solution and the governance and political solutions. In other words, build guardrails, societal guardrails, as well as technological guardrails. In terms of the geopolitics, the way that I think about it is the only way we're going to continue making progress without creating all these terrible risks is if we move eventually into a world where the most advanced AI becomes a global public good that cannot be in the hands of a single person or a single corporation or a single government. It's not sufficient that we rely on market forces to achieve that, of course, and of course national competition also moves us away from this. But I think there are solutions. And there are examples in the past of successes in negotiating between nations to solve big problems that we have. All right. So that's the end of my presentation. Thank you for your attention.
Thank you